Good morning to each and everyone. Welcome to my science class. My name is Mr. Marco S. Hermoso and I will be your science teacher for today. For the most essential learning competency, we are going to investigate the relationship between the amount of force applied and the mass of the object to the amount of change in the object's motion. This lesson will help you develop a basic understanding of the underlying principles of Newton's law of motion. For the learning objectives number 1, state Newton's laws of motion and give situations that illustrate these laws. Number 2, describe the relationship that exists between acceleration and force on an object. Number 3, give and illustrate the forces that act on a body. You will also understand the concept of force and the concept of motion. Force and motion are fundamental to all matter in the universe. And motion is all around you. It's even inside you as your blood moves through your body. And for every motion, there is a force. And in this lesson, you will learn about the forces that make things move, stop, and change direction or speed. To make something move, a force is needed. Lifting, pushing, and pulling are all forces. At times, a person provides the force. And when you lift a stack of books, push a broken down car, or pull a rope in a tug of war game, you are the force. Machines can also provide force to create motion. A huge engine can produce enough force to propel a massive rocket into space. Motors in cake, mixers, fans, and blenders use electrical force to make things move. Nature can also be a strong force. Breezes make leaves dance in the treetops. Ocean waves make boats bob up and down. And forces deep underground cause earthquakes that make the ground tremble. Much of what we know about motion comes from scientists who lived hundreds of years ago, and they conducted tests on moving objects. British scientist Isaac Newton discovered gravity. It is the invisible force that causes things to fall toward the ground. You may have heard that he was the sitting under a tree one day when a falling apple hit him on the head. And the story goes that this accident led him to discover gravity. Isaac Newton wasn't really hit on the head by falling apple. That's just a myth. But over time, he observed that objects always falls down toward the ground, and that led him to discover the gravity. There are a lot of things happening in the world. Objects move, fall, and rest all around us. You may think you understand why things move or don't move, but did you know that the forces acting on these objects can be measured and their motions can be predicted? Renowned English scientist Sir Isaac Newton wanted to understand the world better, and he thought that he could describe the movements of the universe through mathematical observations. In 1687, he published this observation in a book which outlined his understanding of the laws of motion. These three laws of motion are still in use today, and it helps us understand the relationship between a body and the forces acting on it. Newton's first law of motion is often stated as an object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by an outside force. This law is also called the law of inertia. Since the inertia, it is the tendency of an object to keep doing what it is doing. You have experienced Newton's first law if you have ever used a swing on a playground. And in order to start swinging, you have to use a lot of force. But once you get going, it can hard to stop, right? So here on Earth, there are a lot of forces working on objects. When you throw a ball upward, it doesn't keep going up forever because of the force of the gravity. It pulls it downward. Once it hits the ground, friction or resistance caused by surfaces rubbing together will eventually bring it to stop. Newton's second law says that the force is the product of mass times acceleration. Mass is the amount of matter or stuff in an object. And to make something accelerate or speed up, you have to apply force. The amount of force it takes to move an object changes depending on how massive it is. Think about it. You would need more force to move a bowling ball to move a beach ball at the same size. And the greater the mass of an object, the more force it will take to accelerate the object. And applying more force will make object move faster. Newton's third law of motion says that for every action, there is an equal and opposite reaction. If you exert a force on an object, it exerts an equal force back on you. For example, a ball hitting the ground exerts force downward, and the floor exerts an equal force upward. And this is the principle that allows rocket to launch or a jellyfish to swim by exerting a force downward. An equal and opposite force pushes upward and the object accelerates. We can also see the third law in action when birds fly. Their wings press down against the air and the air pushes up against their wings allowing them to move upwards. And another good example of this law is the skateboarding. The skater pushes backward against the ground with their foot, and the ground pushes forward with equal force. Since the wheels of the skateboard reduce the friction between the person and the ground, they are able to move forward for some time before forces slow them down again. Although these three laws were written down more than 300 years ago, they are still important and essential. Now, for the understanding the way things move, and it represents the foundation of the classical mechanics. Thank you so much for watching, and I see you guys on next week for more amazing videos. Goodbye!